Bismillahirrahmanirrahim. Assalamu alaikum students. Welcome to C1 physics class. I hope you are all fine. Try to do as many good deeds in this holy month of Ramadan so that you can achieve the blessings and forgiveness of Allah. In week 6 we have started the chapter forces. We will going to continue this chapter. The subtopics of the chapter which will be discussed today are effects of force, Newton's first law of motion, Newton's second law of motion. Objectives of the current lecture are, by the end of the lesson, students will be able to describe the effects of forces, state Newton's first and second law of motion, apply the equation F is equivalent to ma. Starting with effects of forces, as you know that there are only two possible states for an object. Either the object is in the state of rest or it is moving, and force is required to change the state. Suppose if an object is at rest and force is applied on it, what is the possible effect of the force? It is very obvious, the object will start to move. Now we have to see what happens when force is applied on an object which is already in motion. If force is applied on a moving object, it causes the object to stop moving, or it increases the speed of the moving body. In order to increase the speed of the moving body, the force should be applied in the direction of the motion of the body. If the body is moving towards right, the force should be also applied towards right. That will going to increase the speed of the moving body. If the speed increases, it means that the body is accelerating. If force is applied on a moving body such that it is in opposite direction to the motion of the body, in that case the speed of the body decreases. And when the speed decreases, we will going to say that object is decelerating. A force acting on an object can also change the shape or the size of the object. You must have observed in case of car accidents, they are crushed badly. So the shape and size, it changes due to the violent force which exists upon when during the accident when the car hits another car on or any other object. Forces, they come into play when one object interacts with another. So if a body is in the state of rest, force applied causes the body to move. Over here a box is in the state of rest, the person is applying the force that will going to cause the box to move. If a wheel is in motion, you can increase its speed by applying force. Force is applied over here by the hands on the door, which changes its shape. When you stretch a rubber band, force is being applied and that changes the shape of the rubber band. Actually, the length of the rubber band increases. Again, over here, air is being filled in the balloon by this person. So force is basically being applied and that is changing the shape of the balloon. A girl is driving this bicycle. So the speed of the bicycle is increasing because the force applied by the girl in the forward direction is more. The force can also change the direction of an object. For example, in case of this table tennis match or in case of cricket match. In this table tennis match, when the tennis ball is hit by the racket, the direction of the ball changes. So when it is hit by the racket, there is a force acting on the tennis ball by the racket, due to which its direction changes. Similarly, in case of a cricket match, a ball is thrown by the bowler towards the batsman. The batsman hits the ball with the bat. Upon hitting, a force is exerted by the bat on the ball and that changes the direction. The ball moves away from the batsman. Now we have to discuss Newton's first law of motion. We have done balanced forces and unbalanced forces. If balanced forces are acting, then the state of the body do not change. That is, if the body is in the state of rest, it remain at rest. And if it is in motion and it is moving with constant speed in straight line, it continues to move in constant speed in straight line under the action of balanced forces. In case of balanced forces, the resultant force is zero. So when this is the situation, in that case, the state of the body does not change. So the statement of the Newton first law of motion is that an object at rest remains at rest, and an object in motion continues in motion at a constant velocity in straight line unless acted upon by external force or unbalanced forces. Newton's first law is also said to be law of inertia. So if there is a glass of water on the table, that will be in the state of rest. If you want to move it, you need to apply force. Similarly, if if you set anything in space in motion, it continues to move in a straight line with the same speed, because in space there is no external force, there is no force of gravity acting over there. But on Earth, if a ball is rolling down on the ground, it after covering some distance, it comes to stop. It comes to rest because there the force of friction is acting on the ball due to the ground, due to which the ball comes to rest. So a force is required to change the state. But if the forces are balanced, then resultant force is zero, and in that case, the state of the body does not change. Again, recap of the Newton first law of motion. It is also called the law of inertia. Newton first law of motion state an object at rest will remain at rest, or an object in motion will remain in motion in a straight line at constant speed unless an external force or unbalanced force is acting on it and it changes its state, either the state of rest or state of motion. Explanation of the Newton first law of motion. The behavior of all objects can be described by saying that objects tend to keep on doing what they are doing unless acted upon by an unbalanced force. If the object is at rest, it continue in the same state of rest. If it is in motion with with the velocity of 5 meter per second in east-west direction, they will continue in the same state of motion. That is, it keeps on moving with velocity 5 meter per second towards east. If it is in motion with a velocity of 2 meter per second acting in the left hand direction, the body keeps on moving with the same velocity and in the same direction. The state of the motion of an object is maintained as long as the object is not acted upon by an unbalanced force. All objects resist the change in their state of motion. They tend to keep on doing what they are doing. Friction and air resistance cause a car to come to rest when the engine is switched off. If these forces were absent, we believe that a body once set into motion would go on moving forever with a constant speed in a straight line. That is, a force is not needed to keep a body with uniform velocity provided that no opposing force act on it. Newton's second law of motion. The statement of the law is that the acceleration produced by a net force on an object is directly proportional to the net force is in the same direction as that of the net force, and it is inversely proportional to the mass of an object. So if unbalanced forces are acting on a body, it means that the resultant force is not zero. There is some force, resultant force acting on the body. And if there is some resultant force, that will going to change the speed of the body. Either the speed will going to increase or the speed will going to decrease. If the speed is increasing, the body will be accelerating. And if the speed is decreasing, the body will be decelerating. So whenever there is net force acting, and that happens in case of unbalanced forces, acceleration will be produced, and that acceleration will be directly proportional to the net force. Acceleration is a vector quantity, so its direction will be the same as that of the direction of the net force. And that acceleration is inversely proportional to the mass of the object. According to the Newton's second law of motion, an object will only accelerate if there is a net or unbalanced force acting on it. The presence of unbalanced force will accelerate an object. That is, its speed will going to change and its direction will also going to change. Acceleration produced in case of unbalanced forces, that will be directly proportional to the applied force. So we have A is directly proportional to F. Greater the force applied, greater will be the acceleration. Smaller the force applied, smaller will be the acceleration. And acceleration produced in case of unbalanced forces, when there is a net force acting, that acceleration will be inversely proportional to mass. It means that if mass is small, acceleration will be more. And if mass is larger, there the acceleration will be less. Combining these two relations, the final relation is F is equivalent to ma. F is the force, m is the mass, a is the acceleration. SI unit used for the measurement of force is Newton. 1 Newton is equivalent to 1 kg 1 meter per second square. As you know that SI unit of mass is kg, SI unit of acceleration is meter per second square. So replacing mass by its equivalent unit 1 kg and acceleration by 1 meter per second square, 1 Newton will be equivalent to 1 kg meter per second square. This is the mathematical form of Newton's second law of motion, that is F is equal to ma. This equation tells us that a resultant force F on an object will produce an acceleration a. Doubling the resultant force on an object will double the acceleration. With the same resultant force, doubling the mass will halve the acceleration, because mass and acceleration, they are inversely proportional. If mass is double, then acceleration reduces to its half value. In the last, we're going to do the recap. Today we have discussed effective forces and Newton's first law of motion and Newton's second law of motion. What are the effective forces? If force is acting on a body which is stationary or it is at rest, then it causes the object to move. And if force is acting on a moving object, then it stops the moving object. If force is acting on a moving object, it changes the speed of the moving object. Either the speed increases or decreases. For that case, if the force is acting on a moving body such that its direction is the same as the direction of the motion of the moving body, the speed will going to increase and the body will be said to be accelerating. And if the force is acting on a moving body, it can also decrease the speed. For that case, the force acting will be in the opposite direction to the motion of the body. If speed of the body decreases, then the body will be decelerating. Force can also change the direction of the moving body. Force can also change the shape and size of the object. In case of stretched rubber band, the length increases. So there the force can also change the shape of the body either temporarily or permanently. Newton's first law of motion. The statement is that the first law of motion states that the motion of an object changes only if unbalanced forces act on the object. That is, if the object is in the state of rest, or if it is in motion and it is moving with constant speed in a straight line, it remains in its state unless a net force act or an unbalanced force act. According to the Newton's second law of motion, if there is unbalanced forces acting on the body, there will be some resultant force. And if the resultant force is acting, either the speed of the body will going to increase or decrease. If the speed is increasing, the body will be accelerating. If the speed is decreasing, then the body will be decelerating. So under the action of unbalanced force or the net force, acceleration is produced. And that acceleration is directly proportional to the force and inversely proportional to the mass. The mathematical form of Newton's second law of motion is F is equal to ma. That is all. I hope today's lecture is clear to everyone. Allah Hafiz. Have a nice day.